This conference will now be recorded.
Hello, everybody. Thanks for joining us for the Satellite Book Club seminar series. This is session number 16. Jordan Girth, National Weather Service Office of Observations here. We got a great presentation ahead today. Linda Gilbert's a lead meteorologist at the Weather Forecast Office in Marquette, Michigan. And it's windy up there today. She'll be talking about utilization of GLM products for marginally severe events. So I'm really looking forward to this presentation. Just a few reminders before we get started. First off, this is being recorded, so if you have a colleague that's missing it, they'll be able to go onto VLab and watch it subsequently. And there will be opportunity for Q&A after the presentation. Please feel free to enter your question in the chat room, and we'll try to answer them in the order they are received. And we have Frank Alsheimer, the Science and Operations Officer at the Weather Forecast Office in Columbia, South Carolina, helping with the Q&A moderation today. So thanks, Frank, for joining us. If you are interested in being a future presenter or discussion facilitator for us, please get in touch with our Tower S team, and we'd love to have you. Also, if you're looking for training, we have a training team that can help create materials, or if you're looking for materials that you don't know if they're available, we got Brian Mata and the Oklo team. Just want to extend thank yous to the Tower S team, Lee Byerly, David Blutis, Oklo, Gozar, and JPSS for supporting the Satellite Book Club. Without further ado, I'd like to introduce Linda, who entered the Weather Service more than 10 years ago, I guess all the way up the eastern side of the Rockies, starting at the Weather Forecast Office in Melbourne, then Louisville, then Pleasant Hill, Kansas City, and now Marquette. So maybe she can tell us if Fairbanks or somewhere is next. I'm not sure. Very few offices further north than Marquette. Had a wide array of convective experiences, with each location adding its own flair to how storms behave. The time in Melbourne sparked her interest related to lightning, being introduced to the ground-based lightning detection and ranging network, which is part of the NASA Kennedy Space Center. So I'm glad to have her presentation on GLM as her interest in lightning has grown. Linda, welcome to the Satellite Book Club. Thanks for being with us today.
Thank you so much, Jordan, and good morning, good afternoon to everyone. That's quite the introduction, so thank you very much. And I guess we'll just go ahead and jump right into it. Just a quick side note, because it is so windy here today. Hopefully my audio does not cut out, but if it does, my apologies in advance for that. I've got a backup ready to go in case I do end up with some internet problems. So apologies in advance if the wind plays a role in that. Okay, moving right along. Okay, so first of all, disclaimer, I'm not a quote doctor of lightning, nor do I play one on TV. Consider me to be an enthusiast with respect to lightning and GLM and its uses and whatnot. Some of NSSL, Scott over there at University of Maryland, Chris down there at, I believe it's NASA Sport in Huntsville. So those are the folks that would really be the experts in this particular realm. But like I said, consider me to be an enthusiast. So I wanted to start off here with the conclusions up front. First and foremost is this idea of having a mesoanalyst play a leading role in not just your higher end events, but your marginal events as well. I think this is really key, really crucial, and something that our local SU here has tried to instill in us early on in our convective season, and certainly for good reason. It's an excellent way to maintain situational awareness. Ideally, that should not be the radar operator. That radar operator should, of course, be focused on the warning operations at hand. And so having somebody else perform those mesoanalyst duties, which includes looking at this lightning data, GLM data, is really going to help out your warning decision-making process. And so not having the radar operator be that mesoanalyst, you're able to maintain better situational awareness. But, and I cannot stress this enough, communication between the mesoanalyst and the radar operator is essential. If there's a breakdown in that communication, that's where you might start to run into some issues. use all of the available tools and resources at your disposal. Checklists can be really helpful, and there are 2 checklists that I will just very briefly show you here this morning / this afternoon. And these are things that we've started utilizing here in our office for our convective events. Lightning data, again, conclusions up front, does and can help. There will always, of course, be caveats. So I highly recommend that you develop your own local thresholds and methodologies. And, you know, just because I'm focusing on Upper Michigan, that does not mean that some of this information can't be applied to your local offices or warning operations. And one other thing I really wanted to point out here that came to light as I was working through this presentation in particular is I would love to see more readily and easily available GLM data that would be really helpful for revisiting events. There is a lot of information to digest and unpack with some of that information that is currently out there. Personally, a dream of mine would be the creation and emergence of a GR equivalent tool for satellite imagery. You know, we've got GR analyst for radar. It would be fantastic to have something like that for satellite imagery. And I really want to make sure that I give a special thank you to Ryan Connolly, who's a meteorologist here, who has helped me build some of these images that you'll see a little bit later in the presentation. Okay, so the mesoanalyst process, we're incorporating a modified near storm environment checklist that is courtesy of WFO Grand Forks. So special thanks to Thomas out there from our Sue Nick Langleyib. And another checklist that we've incorporated this year is a hail checklist from my former office at Pleasant Hill. Most of our events do fall into the Donovan method category. And again, this is not something I'm really touching on here in this presentation. So I encourage you to take a look at those outside of this discussion today if you're unfamiliar with these things. But I just wanted to let you know checklists can and do help and does play a role in this entire process. And early on in the convective season, I presented something called All Things Lightning. And this was a great way to introduce, especially to the newer staff that we have here, where they can get lightning data, how can they can utilize it in their warning operations, lightning climatology, all sorts of things like that. So that's something that you might want to consider for your office as well. Okay, very briefly, this is what that hail checklist looks like. And that Donovan method is up there in the top right corner. So definitely check that out if you're not familiar with it. And I can get you some additional information afterwards if you're interested. Okay, so April 7th. This was the event that served as an inspirational start for determining if and how GLM could be incorporated for future events. Unfortunately, I was unable to obtain plotting for this event, but this was definitely a situation where I saw it unfolding and lightning data did play a role in being able to serve as a little bit of a, let's pay attention to what's going on here. So in this particular event, we were looking at a situation where utilizing that locally modified near storm environment mesoanalyst checklist, it was a high shear day. And I would put this more in the low to maybe moderate category for CAPE values for this day. So just to kind of give you a very brief look at what we were looking at here for this particular event. We ended up getting, and again, apologies, I couldn't get a more reasonable plot for you here. But what we were looking at is some convection that was going across mostly Green Bay's area, but did in fact go through our very far south central portion. And we ended up getting a hail report out of this particular event. So like I said, this was a very early event for us. It does actually still snow in April, if you're not aware of that. So the fact that this happened as early as it did, not incredibly unusual, but was definitely the start of, let's take a look to see what we can do in terms of GLM data and incorporating it into that warning decision process. Okay, so the next event here, June 2nd. This was a situation where it didn't look all that impressive, just taking a quick look here at the setup. But nonetheless, it did look like, you know, maybe we could get some feisty storms out there, but this is definitely the event that I would put into that marginal category. It's not something that you're really going, I'm going to pay big attention to, because this is, again, that marginal event that, that this presentation is really built around. We did have a couple of LSRs, a total whopping of 3 issued. Only one of them was severe. And here's a picture here of some of the hail that was falling. This is affectionately known as the bird streets. Thank you very much to our Opal Jim for supplying this picture. But this is just a snapshot of what we were looking at. And this event happened early in the morning. So I'm gonna go ahead and play this video here for you. And I know that we're focusing on GLM, but I actually had the opportunity to capture some Vizsla total lightning data and put this into an animation here for you. And I'll let it play through once and then one more time. If you notice here, there definitely is an uptick in lightning, and it happens fairly quickly. And I'll go ahead and play that again. You can see here, this is right around just after 6 in the morning, local time. That lightning is really starting to pick up there. And those LSRs, if you remembered, happened pretty much right where you're seeing some of those maximum points that are occurring there in just off of Lake Superior there. And here's a take a look at the total optical energy product, and you can definitely see an uptick in the lightning. And I would put this at when I took a look at it, anywhere from about 15 to 20 minutes before the first LSR came through, or the first LSR was issued. It certainly looked like we saw a little bit of an uptick in lightning. And something that I'm not focusing on here either, but ended up being very interesting on this particular day is on the northern part, it started to take off over Lake Superior, so that was very fascinating to watch. The lightning really blew up over Lake Superior as it continued to move out off to the northeast, but we're focusing on the land here. And this is the flash extent density product. You can really see there an uptick in the lightning. Now, remember, you could have some parallax, so that is something to take into consideration when you are doing GLM analysis. But you could see here, it's nice and early in the morning. You've got that sun rising. And I used visible satellite imagery in the background here just so you could see that correlation there between the sun rising, the clouds really starting to pick up there, the lightning starting to pick up there. Just a really cool event that morning. Okay, so very, very briefly, this is not a radar analysis, but I can't not show you this, right? So moving right along here, this is already looking at 1117Z, fairly early in the morning. And you can see here that the reflectivity, had picked up quite a bit. Ishpeming, that area is what we're focusing on. You can see that 1/2 inch hail, 3/4 inch hail, and then there's that severe report 1 inch hail. Comes in a little bit late. But the timing does line up right in this time frame here. We're looking at about 1139 to 1144 Z. You start to see those reports as a result of that radar imagery as those reflectivities are starting to come up. All right, so moving back to the presentation here. Okay, so the next event that I took a look at, this I would put into more of the higher end event for our area. This was quite the couple of rounds of convective complexes that we had moving through our area July 18th and July 19th. Even though these aren't technically falling into the marginal category, I still thought that it was something worth taking a look at to see how GLM could play into even some of your higher end events. I'm gonna warn you right now, this is one of those events where there's a lot to unpack here, just way more than what I can do in this presentation here in the short amount of time. But I just wanted to introduce to you some of the imagery that we had come up with and take a look at some of the lightning data from that particular event. So total optical energy, we had created these images in-house, and you can see here, there is quite a bit of lightning out there. And I did not select every single image that we had available. We actually have way more images available for this event than what is displayed in here. And I'll go back and show it for you one more time. There's just a lot to unpack here. There's a lot of lightning happening consistently across a fairly large area. There are little bits of jumps here and there, but I don't think that those are situations that you should just like, oh man, I gotta consider issuing a warning. This is a little bit more of a complex unfolding event that really, I think the idea is to look more for the trends and to help aid in your warning decision-making process. And the overall trend is that it just kept cycling over and over and over again. So that was the total optical energy, or the TOE product. And take a look here at the flash extent density, or the FED. And I want you to focus here, go ahead and point out my pointer here, in this particular area. You can see here, it's almost like some continued cycling, which is what we saw on radar as well. It certainly looks like you're seeing some lightning that is fairly consistent, going up and down here, up and down. And we ended up getting some reports as it came on shore, the western side there of Lake Superior. And I would not be surprised if some of these reports, you know, some severe weather happened further south, but in this region of western upper Michigan here, it's pretty rural, so it can be difficult to get some reports sometimes. But nonetheless, this definitely is an example of something that can be utilized for even a higher end event. You can watch those trends and see those storms cycling. Okay, so turns out during this event, we did not have a radar, so we had to rely on our neighbors, Duluth and Green Bay. So these are just a couple of quick snapshots from Duluth's radar that morning. And you can see really high-end winds that are coming on shore out there in the western part of upper Michigan. For those that are a little bit more familiar with the area, the Apostle Islands, which is just on the far left side of this image here. I was actually watching this storm that morning, and watching it come on shore, or I'm sorry, that night, late at night. And it was looking pretty beefy in terms of some of the winds that were coming in. So definitely a higher end event for us. And just moving right along here, you can see those winds really coming on shore. Where you see Ontonagon, that area in particular, like I said, this whole area is not highly populated. So I'm sure that some damage had occurred there. Just, you know, it's difficult to get reports. So taking a look at Green Bay's radar, excuse me, same thing. You can see right here, just south of Houghton, Michigan, really good wind signature there, and we did get some reports in that area of some damage and some hail. So kudos to the warning operators that were working this event, having to utilize Green Bay and Duluth's radar while ours was undergoing its upgrade. Okay, moving right along here, August 26th. So this was a very interesting event. We did put out a warning, only were able to get 3/4 inch hail though. But this is another example of being able to utilize GLM for those marginal events. And the other reason why I wanted to bring up this event, which actually split into 2 different times, is at 8:43Z, we actually end up getting a report of some damage due to a lightning strike. So taking a look at the 8Z hour right quick here, definitely lots of lightning in the area. And I want to highlight here the area of interest. This is where this general area here is where a barn fire actually ended up occurring, doing some damage to the 2nd story of a barn there. And that was due to lightning. And here's the flash count density. This is not a situation where, you know, the GLM could say, oh, it looks like there's an uptick in lightning activity, so we're probably going to get a lightning LSR. No, please don't take that away. But you can see those trends, the lightning really starting to pick up as it moved into that area. So again, it's just a matter of situational awareness. Can you incorporate into, if you're going to issue a warning in terms of meeting your other criteria, put in frequent lightning or something like that. Okay, so this is the later event where we had that marginally severe hail, just shy of severe. And once again, it's a little bit difficult to see, but there is just a little bit of uptick in that lightning activity. And this is the energy density product, courtesy of Sierra. And then the flash count density product as well. Again, you see just a little bit of an uptick in that lightning data. again, can be an aid for your warning decision process. Okay, August 31st. Low top supercell. Why am I telling you about this? Well, this is a very interesting case and falls into the caveat category. So we ended up with an EF1 tornado, and this happened just a few days ago. So I put this in here at the last minute. 95-mile-per-hour winds. The WCM went out there and did a survey, path length of just a little over a half mile, 200 yards, duration 2 minutes. Very short duration, low top supercell tornado that ended up occurring to the south east of here in Escanaba, if you're familiar with this area. It was observed and property damage did occur. It ended up collapsing that thunderstorm and creating some downburst wind damage after the fact. So interestingly enough, I went back and looked at this event, and sure enough, it's really hard to see on this particular product, but right here, and this is about 15 minutes before the tornado occurred, you actually do see, boop, a very quick blip of lightning data. So I thought that was very interesting that that was in fact picked up by the GLM. Here's a look at the flash count density product. And again, it happens very quick. You got to squint your eyes to look at it, but it's there. And again, this is about 15 minutes before the tornado, boop, pops up and then disappears. So very low lightning type situation. All right, so moving forward, all of this is just the beginning, and this just barely graces the surface. Some of the goals that I think that we've identified that we'd like to continue working on here is working with our in-house guru, as well as the case review team that we have here locally, to build a local repository, include that GLM data, and see how else we can utilize and incorporate GLM and ground-based data. This was focused on GLM, but as I did touch on a little bit ago with Vaisola, there is definitely some opportunity to make sure that you're looking at your ground-based information as well. Continue to identify those cases of interest and ways that we can utilize and incorporate that. And then a question that we have here locally that I personally have, quantifiable measurement. What can be applied quantifiably when we're assessing storm growth? It looks like specific rates of increase. Is there something that we can identify here locally that we might be able to, place into certain storm events and the evolution of certain storms? Are there things that we can utilize here locally in terms of something that's quantifiable that we can really help with our warning operations? So that's all I've got. Thank you all so very much. This is actually a picture from my very first storm survey in Winter Park, Florida, at the Melbourne office. There was a tornado that ended up occurring, and also this lightning that had occurred to an apartment building and destroyed that entire section, as you can see there. Really, the reason why I wanted to show you this, we all know how dangerous lightning is. Let's see if we can work together to help warn folks and provide the best services we possibly can. So thank you all so much again. That's all I've got. Thank you so much.
Okay, Linda, thank you so much. That was a great presentation. So at this point, we will now move on to the discussion, and we will have time beyond 12:30 for some extended discussion. So if you could stick around, that'd be great. But if you would like to submit a question, I see we already have one in there in the chat room. Feel free to drop that in or any comments. And if you'd like to ask a question verbally, go ahead and indicate that. We can make sure we can unmute you. So this time I will turn it over to Frank, and he will be facilitating our discussion. Frank, take it away.
Thank you. Let's start with, we have a question here from Aaron Poyer. You mentioned the Donovan method and the uptick in electrification. I would think presumably in the mixed phase period that coincides with the hail reports or chances. Have you also used GR2 to look at the KDP during these time periods? And if so, do you see any correlation in the location of the radar indicating the mixed phase with the lightning uptick in hail reports downstream?
Yeah, so for the purposes of this particular presentation and what I was doing for putting together to see about that, no, I have not had the chance to look at that, but that's a great point there, Aaron, and I think that's definitely something worth exploring a little bit deeper. So thank you very much for those thoughts.
Okay, another question. This one's from Tim Schmidt. Might the process be streamlined or documented for forecasters being able to drop in nationally archived GLM, or even for that matter, ABI data, into a West type local AWEPs for case studies?
That is an excellent question that I also have. Yes, that would be great. How can we make that happen?
I think every Sioux in the
If
country
anybody has
has
any
that same
thoughts or ideas
question.
on that, please. Yes.
Okay, I've got one more. I want to make sure we get one more question here, and then we've got several beyond that. One of the biggest sources of marginal severe events in the warm season are the single cell pulse severe events, mainly in high cape, low shear environments. How could local forecasters use the GLM information you presented in those scenarios?
So yeah, that's an excellent question, and that's definitely a situation where I think that anecdotally speaking, we can say that there's going to be an uptick in GLM activity, and you can equate those upticks to the strengthening of a storm, and so. The bottom line is that I think that the evidence is there beyond any of the work that I've personally done. But I certainly think local areas trying to figure out what kind of trends you're seeing in your particular area, what works, what can be applied. And going back to that, let me go back here to that one question that I personally have, and that is quantifiable measurements. What can be applied quantifiably when we're assessing these types of storms, no matter what environment it is? Can we really take a look at and see if we can apply some of these same types of checklists that we have for these high cape
It sounds like we lost her audio, at least temporarily. Maybe I'll kick it back over to Jordan.
and make sure that we
Go ahead and finish, Linda.
Oh, sorry. I was just going to say that, yeah, it's something that you want to take a look at locally. And I think that there's a lot of use here. There are things that we can do for sure. It's just a matter of getting our hands dirty and doing it.
Okay, we're going to pause here. I realize some of you might have to get back to work, but for those of you that want a continued Q&A, we'll keep the GoToMeeting running. Just want to thank Linda and thank Frank for being with us today, and thank all of you for attending. Next week, Thursday, September 10th, at 12 noon Eastern time, we'll have Dave Riddell, who's the SUE at the Weather Forecast Office in New York. And he's going to be presenting on the GO16 fog and low stratus products that have been used to support aviation forecasting. There is a link for feedback that will be appearing in the chat. Feel free to take that survey if you have an opportunity or want to let us know how we're doing with the Satellite Book Club. And just a reminder, there is a new Tower S RPM out there. If you need any assistance installing the Tower S RPM and getting that new satellite data into your field office, please contact John Evans and Lee Byerly for more information on that and perhaps setting up some time to work with you. So with that, hope everybody has a good Labor Day weekend, whenever that comes for you. And we'll turn it back over to Linda and Frank for a little more Q&A. Thank you.
Okay, yeah, we got a couple more questions lined up, and actually Bill Lyon is asking a question that's similar to mine, so I'm going to combine them into one. You know, we're talking about, of course, marginal severe events, but it could certainly be for other severe events. when you walk in as the radar operator and you know that you're dealing with at least a potential marginal severe event, how would you set up your D2D to make good use of GLM in your warning operations?
So, like I said, ideally, now, of course, staffing comes into play in all of this discussion. But ideally, you would have a separate mesoanalyst, even if that mesoanalyst is performing other functions and roles in the unfolding event. You as the radar operator, I think that you can certainly have, like, maybe you have a 4-panel up of the different GLM products, your ground-based stuff, because it is nice to be able to make sure that you're taking a look at both the GLM and the ground-based stuff back and forth, and incorporating all of that into your process. And having IR satellite imagery or something else, whatever your satellite imagery of choice is. So having that up just as a situational awareness point is great. If you can really do it though and manage it, personally, I think the way to go is to have a separate mesoanalyst to be able to dive a little bit deeper into taking a look at some of those trends. Because as a radar operator, even in marginal events, and I'd argue maybe even more so in marginal events, there's a lot on your shoulders and on your plate in terms of diagnosing the storms, the trends, do I, don't I warn. It can be a little bit more challenging than in some of those, oh, this is a supercell, I should probably warn on this. Those types of situations, I don't want to say are easier by any stretch of the imagination, but the marginal events can be pretty challenging in and of itself. And I think that's why it's important to have someone else assisting the radar operator, but certainly have some sort of like 4-panel up, because that's what I personally do. Something that I've helped with my radar operations is having that data up so I can quickly take a look at it. But if I have other questions, maybe I'll ask someone else to do a little bit of a deeper dive in diagnosing some of those lightning trends.
So would you say then you're not really actually making warning decisions based on the lightning data, instead you're using the mesoanalyst to take advantage of the lightning data?
That's what I'm personally proposing. So I kind of see this as when it comes to like our decision support services, for example, we're not telling the emergency manager or the partner what it is that what they should be deciding to do, right? All we're doing is feeding them the information that they need to be able to make those decisions. So I kind of see a little bit of those similarities between the mesoanalyst person and the radar operator. The radar operator has a lot of information that they're taking in, they're processing at the same time. So having somebody be able to feed that information to them and say, hey, look, I'm noticing a trend here with respect to some of the lightning data, that could help assist in the warning decision-making process. Maybe it looks like that storm is really starting to tick upward. Okay, I'm gonna go ahead and pull the trigger. I was on the border with it, but you just let me know that you're seeing an upward trend here. Great, that's helps me to make the decision process a little bit easier. And then vice versa. Oh, it looks like this storm is collapsing. Maybe put out a short duration warning. Maybe you don't need one at all. But working together to be able to help make it a little bit easier for that warning decision process is ideally. Now, of course, we all know that's not necessarily how it plays out in the real world, but ideally, I think that would be the way to go.
Okay, thanks. I've got another question from Brian Mata. Do you have access to the total optical energy and average flash area grids? And if so, how do you use them to make forecast or warning decisions?
So we have access to the total optical energy grids. I'm going to have to double check. We ended up with an upgrade a couple of weeks ago. I can't remember if the AFA is available to us specifically, but I had the opportunity to use AFA at some of the preliminary stuff that was coming out of the hazardous weather test bed last year with respect to AFA and the potential that can be used for those warning decision processes. So if we don't already have access to it, that would be great to see in the near future, because like I said, I felt like there was a lot of promise there in being able to use that in the warning decision process. Oh, I'm sorry, yes, you're right. Minimum flash area was in the HWT last year. But yeah, So minimum flash area is what I was talking about. Thank you.
Okay, more kind of a general question that leads to the theme of your presentation today. Obviously, the biggest attention in the press is focused on the big severe weather outbreaks, especially the ones that do lots of damage. Why are marginally severe events like the ones you demonstrated today also important to consider in a forecast office?
So I want to make sure I understand the question. Why are marginal severe events important to consider?
Yes.
Okay. Well, because marginal events can be impactful for folks as well. And so, you know, you want to make sure that you're providing the best possible service, right? So if it's a situation where, you know, it's thing that we want to make sure that we're still providing the best possible service to, because it still could be very impactful to, like, for example, we have a large camping community up here in the summer. And so just because 3/4 to 1 inch hail might not do a whole lot of damage, that still could be fairly impactful for all of those tenters that are out there camping. So lots of considerations, I think, play into making sure that we are doing due diligence and paying full attention to marginal events just as much as we are paying attention to some of those bigger events, because they are impactful. We just don't hear about them as much.
Okay, we got a question from Brian Gockel. One of the bullets on one of your earlier slides said something to the effect of it would be good if lightning data was more easily available. Were you talking about the real-time data or archive data? And if it's real-time, did you mean GLM specifically or just lightning in general? And also, what about the current availability actually needs to be improved? Is it getting the data to your office? Is it new products needing additional parameters or exploiting it once it's there? There's a lot of questions in there in that one question, but I think what essentially they're looking for is maybe some expansion of the concept that you mentioned. You know, what do you mean by when you say lightning data more easily accessible?
So yes, my apologies for not making that more clear. Archive data specifically. So going back to that very first event that I talked about, April 7th, for example, that is an event that I would love to be able to go back and do a little bit of a deeper dive on because I know that the trends were there. I was able to see during that event, but I wasn't able to capture some of the imagery from that event in particular. But there's definitely some value to going back and looking at that archive data. So let me clarify, the data is available, but being able to use it in a meaningful way when it comes to diagnosing and revisiting past events has been challenging. And there have been a few of us here locally that have tried to make this usable for our area. And like I said, it's been challenging. The data is there, but being able to display it and use it in a meaningful way, that's been the most challenging thing. And some of the archive data, like for example, the information that's available from the University of Maryland site is a little bit different from the data that you'll get from the Google Cloud or Amazon Cloud data sets. So yes, it's available, but as somebody just mentioned, it's a little bit challenging in terms of being able to visualize it and use it in a meaningful way.
So what would you think of, and you know, maybe I'm getting too far ahead, but like what kind of, say, additional GLM or GLM based fuse products do you think could be beneficial for forecasters? I know, you know, obviously there's the Prob Severe product from Sims out there, but are there other products like a flash extent density jump or difference or something along those lines, or fused flash extent density, or, you know, the tow with something else? Do you have any like brainstorming concepts or ideas where those types of products might become useful versus the difficulty with, as you mentioned at the beginning, I think every forecaster struggles with this, is getting all the data. I mean, it's just a you know, to use the old cliche fire hose of data and be able to make a decision every couple of minutes on issuing a warning.
So I think the first thing that comes to my mind is going back to that idea of trying to define how lightning is going to respond in certain situations. Using your example earlier about your, what was it, high cape low shear type situation, if I remember correctly. So I guess I visualize it as, is there some sort of like, maybe it's a trend line that shows, okay, there's an uptick in lightning activity here. You might want to pay attention to this particular cell or complex of cells, or vice versa. I'm seeing a downward trend. Maybe the storm's about to collapse. Maybe that's a situation where you should still keep the warning going because the storm is collapsing, or whatever the case may be. But I guess I just visualize if it's some sort of way to maybe have like a trend line. That's just the very first off the top of my head. And I don't know, what do you think? Like, you know, is that an idea in terms of, is there some sort of like, okay, it looks like there's an upward trend here or a downward trend that could help? I think that would be something to visit.
Yeah, there's certainly lots of things, and we won't solve this problem here this afternoon, but I appreciate you thinking about it. I do have a question from Jason Eagle. I don't know if the facilitators can unmute him so he can ask his question.
Yeah, can you hear me?
Yes, we can hear you.
All right. I had a question. You know, a lot of times to get the uptick of the potential uptick of the lightning, the vertically integrated ice MRMS product would give you the earliest indication compared to some of the ground-based lightning data networks and some of the other things available. Have you guys considered taking a look at VI and what numerical jumps could be pertinent in the area of vertically integrated ice, the MRMS product?
Right, yeah, that's a good point. And I don't remember if there was another individual who was looking at that locally or not. So I don't even want to speak to that. I personally have not. But I could be wrong, but I thought there was a local individual that was taking a look at some of those things. But yeah, excellent point.
I mean, I have used that in marginal warning situations, especially as you start to approach the cone of silence and then you start to run a little blind. If you get an uptake with that, maybe that would tip the scale, so to speak, and things like that.
Right, okay, yeah.
Okay, we've hit 12:45 Eastern time and 45 after whatever other hour y'all are on as you've logged on. So I think we need to kick it back to Jordan to wrap up. I really appreciate, Linda, both your presentation and your tenacity at answering all these questions. I think you got some good ideas, and it was very worth sharing to the group. So thank you for that, and I'll take it away, Jordan.
Thanks, Frank. Thanks, everybody. That was a great discussion. And Linda, I agree. That was a wonderful presentation. Very, very clear, very applications oriented, which we appreciate on this call. I gave the full wrap up at the bottom of the hour, so there's really nothing additional to say. We've got the Tower S team that's accessible to you there. Hope you'll join us next week. And again, take care, stay well, and have a good end of the summer. Thanks, everybody.